Okay, so problems and solutions. So in A, we had a circle. It has 2 points with a 118-degree arc. It is a 118-degree arc. And then it is connected to a point over here. And this forms an inscribed angle. And the inscribed angle is x. So the inscribed angle theorem that we learned is that oops. In problem B, we have a circle. We have 2 points with an arc measure of x, and they're connected to an inscribed angle, and that inscribed angle is 41 degrees. And this is just using the inscribed angle theorem in reverse, which would mean that x is going to be double the inscribed angle. So in this case, x would equal 2 times 41, so x would be 82 degrees. All right, C, getting a little more complicated here. We have a circle. We have center C. We have a diameter going through center C. And we have a right triangle because we know that we have a 90-degree angle here. We know that this arc measure is y, and we know that this arc measure is z, and the arc measure out here is x. And we know that this angle right here is 78 degrees. And our goal is to figure out x, y, and z. So in this problem, we have to spot the inscribed angles and their arcs. So the arc from here to here is y, and these 2 points connect to this point, which makes 78 degrees an inscribed angle on this arc. So that would mean that y equals 2 times 78 using our inscribed angle theorem. So let me do that quick in my head. So 70 times 2 is 140, and 8 times 2 is 16. So this would be 16 and 140, so 156 degrees. Okay, so y is 156 degrees. Okay, now there's a few ways we could get the rest of them. X is going to be pretty easy because this is a diameter. X is going to have to be 180 degrees because that's what that central angle would be. Now there's some other ways we could have gotten that as well. One option would be figuring out z first. So notice that this is 90. So again, we could do 90 times 2 and get 180. That's a way to get that. Another option would be I could figure out this angle. I could do 180 degrees minus 90 and minus 78. So 180 minus 90 would be 90, and then 90 minus 78 would be 12. So this angle is going to be 12 degrees. Notice that the arc z, right, from here to here, is connected to this angle. So this is a 12-degree angle inscribed on arc z. So z is going to be double 12, which would be 24 degrees. Now, one good thing to check here is that all of the arc measures around a circle should add up to 360 degrees. So we could do 156 plus 24, and that gets us, well, 156 plus 4 would be 160, plus another 20, so that's 180. So this is 180, this is also 180, and that makes a full 360 degrees. We have a circle. We have 2 points with an arc measured at x. We have the center of the circle, and we have dotted lines pointing there with a 56-degree angle there. And then we have these 2 points connecting in to another point, and this angle is called y. And we need to solve for x and y. Okay, the first thing we should notice is that this is the center of the circle, and these 2 points connect to it. So the arc measure between them is the same thing as that central angle. So x is 56 degrees. Y is an inscribed angle from that arc. So remember, the inscribed angle theorem that we're using in this lesson is that the inscribed angle is always half of its corresponding arc. So that would mean y is going to be 56 divided by 2. Let's see, half of 50 is 25, half of 6 is 3. So this would be 25 plus 3 would be 28. So y is going to be 28 degrees. Okay, in E, we have a circle, and we have center C. We have a diameter dashed through it. We have a line connecting here to here. And I think we're being told that this angle right here is x. And we're told that this arc from here to here is 114 degrees. And we're told that this angle, because we also have a dashed line connecting here to here, we're told that this angle is y. So our goal here is to solve for x and y. The first thing I notice in this problem is that this arc connects to this central angle. Remember that an arc measure is the same thing as a central angle. So in this problem, x is 114 degrees. Now I want you to notice that these 2 points that form that 114 degree arc are then being connected to this point. So in other words, if you get rid of the rest of the diagram, it's kind of confusing the picture. If you just focus on this part, we can see that y is an inscribed angle on a 114 degree arc. So that means that y is half of 114. So half of 100 is 50, half of 14 is 7, so this would be a 57 degree inscribed angle. All right, in problem F, we have line cutting across there and there with an arc labeled as x. We have that this angle is 28 degrees. We then have a dashed line cutting down from here and here, and we have y. What I want you to notice first is, what if we ignored the dashed line stuff? If that wasn't part of the picture, and we just had this question, I'm hoping this one's really easy. We have this arc measure is x, and it's connected to a 28 degree angle, inscribed angle. And remember that that means that x will be double 28. So we're going to double 28. So 20 times 2 is 40, 8 times 2 is 16, so 40 and 16 is 56. So x is going to be 56 degrees. Okay, now let's focus on the dashed line part that we had. So this point goes down here, this point goes down here. And what if we actually ignored this stuff, the solid line piece? And we just had this problem. We have a 56 degree arc, and the question is, what's its inscribed angle? Well, the inscribed angle has to be half of its arc. So it's going to be 28 degrees. So x is 56 and y is 28. Okay, as usual, if you have any questions, let me know, and we will have I can always respond to those, and I'll see you guys next week for more with circles.